It's time to jump into the second part of our program today. So who will be on stage? Susanne Kaiser is an independent tech consultant from Hamburg, Germany. Susanne is supporting organizations with building socio-technical systems. She is passionate about connecting the dots between Wardley Mapping, domain-driven design, and Team Topologies as a holistic approach to design and build adaptive systems for a fast flow of change. Susanne was previously working as a startup CTO and has a background in computer sciences and experience in software development and software architecture since 2002. She is the author of the book Adaptive Systems with Domain-Driven Design, Wardley Mapping, and Team Topologies, Architecture for Flow. So please welcome on stage with a warm applause our next presenter, Susanne Kaiser, with Adaptive Socio-Technical Systems with Architecture for Flow.
Thank you so much for the introduction. Thank you so much for attending this talk. And I'm not sure if it's worth having the talk before lunch or after lunch. So I hope you still have energy to follow my talk about adaptive socio-technical systems with architecture for flow. So it's not working, so that's the first test. I stay here to, okay. So can you guess what these companies have in common? It's more rather a rhetorical question. So they have in common that they don't exist anymore, or at least not with their core business. All of these companies filed for bankruptcy or sold their core business. But why? What was the reason that those companies shut down or sold their core business? The major reason were the failure to adapt. These companies failed to adapt to new and changing circumstances so that they were forced to file for bankruptcy or selling their core business in the end, which led to massive job and financial losses, not only in the US, but also worldwide. These cases led to more than 200,000 lost jobs and more than 220 billion US dollars of financial losses, such as creditor cost, lost revenues, and declined market shares. So their failure to adapt led to a massive damaging impact on companies, their employees, and also their stakeholders. The ancient Greek philosopher Heraclitus said, "The only thing that is constant is change." Maybe the change rate was slightly different 2,500 years ago than today, but looking only 20 years back, the change rate and evolution cycles have increased rapidly to the exponential pace of technology advancement. So in today's fast-paced business environment, companies and organizations have to continuously adapt and evolve to remain competitive and to stay relevant in the market. So how to design and build systems that are equipped to adapt easily and respond to changes quickly, and that can evolve and thrive in the face of constant changes. One approach that I would like to tackle today, or to tackle the situation from a rather holistic view and combining various perspectives. So it requires to understand the business landscape and competitive business landscape and organizations operating in, including the external forces impacting the landscape. It requires to gain domain knowledge and know the business domain and closely align the system to the business need and to the business strategy. And also it requires to align the teams to and involve their interaction to the system we build and the strategy we plan. And with other words, one approach could be, out of many, connecting the dots between Wardley Mapping, domain-driven design, and Team Topologies. So let's do this. Let's demonstrate this approach by using an example of an online school solution for junior students. And we can start with gaining a common understanding of the business landscape the online school is operating and competing in by creating a Wardley map. A Wardley map is visualizing the landscape of an organization, and it's part of Wardley Mapping. Wardley Mapping was invented by Simon Wardley, a researcher from the UK. And Wardley Mapping helps you to design and evolve effective business strategies based on situational awareness and movement. When creating a Wardley map, we start with identifying the users and their user needs. They are representing the anchor of the map that all subsequent components relate to. And the users could be your customers, your shareholders, business partners, internal users, and so on. So we are focusing in this example on the teachers and the students as the customers, as the users of our online school solution. And the teachers, they have the user need of creating course content, planning a class, helping the students during their learning progress, evaluating the students' learning progress. The students have the user need of studying courses, requesting and receiving help, and also receiving evaluation feedback. And both needs to sign up and sign in as well. And those user needs are directly or indirectly fulfilled by a chain of components delivering value to our users, represented at the value chain on the y-axis. And the teachers and students, they are interacting directly with the online school component. So that is that's most visible to the users, and it's at the top of the value chain. And at the current state, we are dealing with a monolithic big ball of mud as one single component that we are going to decompose later when we come to domain-driven design. And the online school component depends on other components, such as infrastructure components, such as search engine, data storage, message broker, SMTP server, compute platform running on top of a virtual machine component. So they are less visible to the users and placed further down the value chain. And the components of our Wardley map are typically mapped to evolution stages from left to right. So at the left, we have Genesis with brand new things, then custom build, then product and rental, such as off-the-shelf products or open source software solutions, and then commodity and utility at the right. And each evolution stage come with different characteristics. So towards the left spectrum of our Wardley map, our components are changing far more frequently than on the right spectrum of our Wardley map. On the left spectrum, we're dealing with high level of uncertainties, with unknown unknowns, with an undefined, poorly understood market. And the components on the right spectrum of our Wardley map are far more stable, known, well understood, industrialized, standardized, and the markets are mature and well defined. And we can use these characteristics to determine the stage of evolution of our components in our Wardley map, in our value chain. So the online school component is reflecting a volatile component that is changing frequently and providing competitive advantage. So that shall go into custom build evolution stage. And the infrastructure components are more stable, standardized, well-known, widespread. This can go into product and rental or a commodity and utility evolution stage. At the current stage, we are using mostly open source software solution for infrastructure component residing in product and rental evolution stage. So this is our very first iteration of our Wardley map, and we are iterating on top of it and make it more fine granular during the discussion. And we are using this as a foundation for future discussions. And the Wardley map itself provides a structured way to discuss and generate a common understanding of the landscape we are operating within a group, and also challenge our assumptions in order to create or share this map and create a better understanding and a better, better map of our landscape. But that also helps us to identify areas where our organization can innovate, where can we improve efficiency or also outsource to gain competitive advantage. But that requires also to understand the external forces that impact our landscape or influence our landscape. And that's where we come to the climatic patterns. So climatic patterns, they describe external forces, external rules that are impacting or influencing our landscape over which we have no control. However, understanding the climatic patterns is important to anticipate change, according to Simon and Wardley. So understanding those climatic patterns gives us an idea where the landscape can change and where to invest in the future. And one pattern is that the landscape is never static but very dynamic, so everything evolves from left to right through the forces of demand and supply competition. For example, cloud-hosted service reflect this climatic pattern. What was decades not existent evolved through genesis, custom build, became product and rental, and now commodity and utility. Or large language model evolves thanks to competition-driven technology advancement and are now available as products. And the standardization and industrialization of components increases efficiencies. And this brings us to another climatic pattern that efficiency enables innovation. So the industrialization and standardization of components and its efficient provision enables the innovation of others. It enables that, for example, new features of existing products can appear, or that other components can co-evolve, or that new components can emerge. And it's the genesis of new components that enables new user needs and create future source of value as another climatic pattern. So understanding the landscape and understanding the climatic patterns helps us to anticipate opportunities from a business strategy point of view to identify areas of potential change and where to innovate and invest to gain competitive advantage. But before applying those changes and investments, we have to assess how well we are equipped as an organization to respond to those changes quickly and absorb those changes gracefully. For example, to assess responsiveness to change, we can assess how a change would flow through our system. We could assess what components are entangled in that change and how these entangled components are then coupled together. For example, when we would like to introduce a functional change, in this case, for example, a new feature serving the course content creation user need, that requires to make a change in the online school component. The online school component is currently a monolithic big ball of mud with a messy model and no clear boundaries. So it is impossible to modify only one part independently without impacting others. And we are dealing with tight change coupling. And tight change coupling impedes our extensibility and it slows down our responsiveness to change. And since Conway's law, we know that we have to consider not only the technical part of our solution, but also the socio-related part of team organization as well. But and the teams of our online school example are currently organized as functional silo teams. So introducing a functional change from front end to back end requires communication and coordination between multiple teams. So it requires the UI teams to make front-end related changes, hand it over to the back-end teams, which are then adjusting the business logic in the online school component, hand it over to the infrastructure team, make changes to, for example, database schema, search and index, message format of the message broker. And due to handover, the functional silo teams have to deal with high communication and high coordination bandwidth between teams and wait time when implementing and releasing changes. And blocking dependencies and high communication and coordination bandwidth between teams that slows down our software delivery performance and our responsiveness to change. In addition, the big ball of mud with its messy model and no clear boundaries leads also to high team cognitive load and lack of clear ownership boundaries. So, and if the team cognitive load is largely exceeded, that becomes a delivery bottleneck, also impeding our responsiveness to change. And you can complement this assessment also with doctrinal principles from Simon Wardley. So he has collected roughly 40 different doctrinal principles, and those principles describe universal principles that each industry can apply regardless of their context. And applying those doctrinal principles enables organization to be able to respond to changes quickly and absorb changes gracefully. So, and when applying domain-driven design and team topologies, we are applying some of the Wardley doctrinal principles automatically out of the box. So at this stage, our current system, including team organization, is poorly equipped to respond to changes and poorly adaptive to changes. So how to change that? So to increase the responsiveness to change, we need to design adaptive socio-technical systems that are optimized for fast flow of change. And this can be achieved as one project of many by combining Wardley Mapping, domain-driven design, and team topology as architecture for flow. And we can use, to start this, we can use our previously created Wardley map as a foundation for future design and architecture consideration, also investment discussions. And optimizing a system for fast flow of change requires to know where the most important changes in our system occur, the streams of changes. And the type of streams can differ in every organization, so they can range from role, task, activity, customer segment, geography-oriented stream types. In the current online school example, we are focusing on the activity streams which are represented by the user needs. So the user needs of creating course content, planning a class, helping students, evaluating students' learning progress, and so on. They are good candidates for streams of changes, and they must be focused on when we're optimizing our system for flow. And the users and the user need not only represent the anchor of our Wardley map, but also represent the problem domain itself. And that's where we come to domain-driven design. Domain-driven design helps to gain domain knowledge and also to partition our problem domain into smaller parts, the subdomains. But not all subdomains are equal. Some subdomains are more valuable to the business as others. So we have different types of subdomains. The core domain, that is the essential part of our problem domain, providing competitive advantage, and that's where we should invest most strategic activities on. So the user needs of, for example, of creating course content, planning a class, helping students and studying courses, these user needs fall into the resort of the core domain providing competitive advantage. And they also provide a high level of differentiation. So buying or outsourcing these parts of our system would jeopardize our business success. Instead, we need to custom build those components in-house. The evaluation of student progress does not necessarily provide a competitive advantage, but it supports strategic experience and is necessary for our organization to succeed. So these user needs belong to a supporting subdomain. They support the core domain. They do not provide competitive advantage, but without them, it would not. They are needed for our organization success. And if possible, we should look out for buying or using off-the-shelf product or open source software solution. And if this is not possible and we need to custom build this subdomain, we should not heavily invest in that part of the system because it does not provide competitive advantage. The user needs of signing in and signing up, they embody user need of a generic subdomain, the third type of subdomains. And these generic subdomains are subdomains that many business systems have, for example, authentication and registration. They aren't core, they provide no competitive advantage, but businesses cannot work without them. They are usually already solved by someone else. So for those generic subdomains, we should focus on buying or using off-the-shelf products or outsourcing to utility suppliers for this generic subdomain. So the three types of subdomains, they help us to prioritize our strategic investments so that the most investment should go into the core domains providing competitive advantage. And also they support us with build, buy, and outsourcing decisions. So going no further down the value chain, the solution of our subdomains that we have identified so far They are all mingled together in this tightly coupled big ball of mud with a messy model and no clear boundaries. And to be responsive to changes, the architecture of our online school component needs to leverage modularity with high functional cohesion and loose coupling. So we need to decompose our online school component into modular components, and that's where domain-driven and the bounded context of domain-driven design can help us. A bounded context in domain-driven design groups related business behavior together and forms a unit of purpose, mastery, and autonomy, and also defines where a single domain model can be applied. And bounded contexts also serve, on the one side, they are good seams to split the system apart, but also serve very well as well-defined ownership boundaries. We come to that one in a second. And designing bounded context and the related corresponding domain model involves a close collaboration between domain experts and development teams to gain a common understanding of your problem domain. And there are several techniques available, such as event storming, domain storytelling, example mapping, and so on. So let's say we have applied some of those techniques and we have designed several bounded contexts. So the bounded context of content creation, class management, core study, and learning support, they fulfill the core domain-related user needs and subdomains. So they are strategically important, they provide competitive advantage, and they should require the most development effort. So they go into the custom-built evolution stage, are built in-house. And the bounded context of student evaluation and notification handling belong to supporting subdomain-related user needs. And there might exist solutions on the market already. However, the teams decided that a higher level of specialization is needed and to build them in-house. However, their development investment should not be too high since they do not provide competitive advantage. And the identity and access management bounded context belongs to a generic subdomain. So there exist several solutions on the market already, and it should go either into product and rental or commodity and utility evolution stage. The next step in architecture for flow is finding suitable team boundaries. And as I mentioned earlier, the bounded context serves very well as well-defined ownership boundaries. So bounded contexts are indicating, on the one side, good seams to split a system apart, but also work as suitable team boundaries for stream-aligned teams, and that's where we come to team topologies. Stream-aligned teams are cross-functional autonomous teams, first introduced by Matthew Skelton and Manuel Paes from their book Team Topologies. Manuel's also giving his keynote tomorrow morning about team topologies. And stream-aligned teams are cross-functional autonomous teams that are aligned to a continuous stream of work, and they are focusing on a fast flow of changes. But to be able to produce a steady flow of feature deliveries and to be able to focus on a fast flow of changes, the stream-aligned teams need to get help from other teams. For example, they need to get help from the platform teams. And the platform team, they support the stream-aligned teams delivering their work, and they are responsible for platforms that the stream-aligned team can easily consume. And the platform themselves, they can vary in its level of abstraction. For example, at a lower level, the platform can abstract away infrastructure, networking, cross-cutting capabilities. And in the higher level, a platform can also abstract away a design system, machine learning model, or a data platform. And the platform team, they can provide internal self-services and tools that the other teams can then easily consume to use that platform that the platform teams are responsible for. All these stream-aligned teams can get support from the enabling teams, and the enabling teams are more internal coaches in the organization, and they help the stream-aligned teams to identify and acquire missing capabilities. All the stream-aligned teams can get support from the complicated subsystem teams. This is an optional team type, And they are supporting streamlined teams on particularly complicated subsystems that require very, very specialized knowledge. And all of those teams, they are aiming to increase the autonomy and reduce the team cognitive load of the streamlined team to then enable fast flow of change in the end. To arrange these teams in this team time is not enough to become effective. How these teams are interacting with each other and when to change the interaction is also very relevant for organizational effectiveness. So with collaboration, teams are working very closely together over a limited period of time, and it's suitable for rapid discovery, for example, when exploring new technologies together, but collaboration is meant to short-live. X as a service suits well when one team would need a component library, an API, also a platform that can be effectively provided by another team as a service. And it suits well where predictable delivery is needed. And facilitation comes into play when one team would benefit from active help from another team, and this interaction mode is typical for enabling teams. As mentioned earlier, the bounded contexts serve very well as well-defined ownership boundaries, but streamlined teams also rely on other teams supporting them delivering their work. And that requires then also identifying services that are needed to support a reliable flow of change that can then form an easily consumable X as a service. So in our example, we can focus on the infrastructure components that are mostly located at the product and rental evolution stage that can then be provided as a service by a platform team. I'll come to that one in a second. So the previous consideration might result into this illustrated team constellation as a first draft in a simplified example. A mouse team in an organization shall be responsibility team with end-to-end responsibility. And to achieve clear ownership boundaries, for example, the bounded context that I was talking about, they should not be shared across teams. Instead, one bounded context should be owned by one team only. However, one team can own multiple bounded contexts. So in this case, the 4 core domain-related bounded contexts are going to be split among 3 streamlined teams. The supporting and generic subdomains-related bounded contexts are going to be handled by another streamlined team, and the infrastructure components are handled by one or more platform teams. Another aspect of architecture for flow is also to mine potential efficiency gaps. And from the climatic patterns, we have learned that everything evolves through the forces of supply and demand competition. So if the evolution stages of components that we use in our organization differ from equivalent components available in the market, that might indicate an efficiency gap. For example, if we are custom building components in-house, but there exists an equivalent component available as commodity in the market, then we might lag behind, but then we might be confronted with inefficiencies. And closing this inefficiency, that would increase our efficiency, and also we have learned earlier from the previous climatic pattern is efficiency-enabled innovation. So more efficient we get, the more innovation or focus on innovation we can achieve. So in closing, one approach to close this current efficiency gap of our infrastructure component could be, for example, through a cloud migration journey by replacing our infrastructure component with cloud-hosted services. So at the moment, we have not transitioned anything yet. We have not touched any code, not reorganized anything yet. So how to transition into our target architecture for flow? And the transition can be kicked off by a team-first approach. So optimizing our system for fast flow of change is led by dynamically reteaming the functional silo teams into streamlined and platform teams and evolving their interaction along a cloud migration journey. And also Heidi is giving a talk later on about dynamic reteaming, highly recommended to stay here on the same stage. And so in our case, the transition starts with forming a platform team first from members of the previous backend and infrastructure team. And this first platform team kicks off then the replatforming cloud migration journey and works as the site. And with replatforming, we are replacing our on-premise infrastructure components incrementally by replacing them with cloud-hosted services while we keep the application's architecture the same. And once the infrastructure components have been completely replaced with cloud-hosted services, then later on the infrastructure team, the previous one, can merge into the new platform team and can be split later into multiple platform teams. Next, the streamline teams form, and they form from previous members, for example, from previous members of the front-end and back-end teams. And the streamline teams, they now take care of the refactoring journey. And with refactoring, we are now splitting our monolithic big ball of mud apart into smaller parts. We are now focusing on decomposing our big ball of mud into the bounded context and the modular bounded context that we have designed before. And this refactoring journey is supported by an evolution of Team Topologies interaction modes. So the first formed streamline teams that can, at the beginning, closely collaborate with the platform team and assess potential cloud options that could be applicable for the bounded context that the first streamline team is responsible for. For example, the first streamline team might decide to refactor their bounded context using serverless technologies or serverless compute. So in this close collaboration between the platform team and the streamline platform team can then evolve into limited collaboration and become then later X as a service, where the platform team then provide best practices, tools, APIs that the streamline team can easily consume then the cloud services from. And then the next streamline team can form and refactor their bounded context, and that next new formed streamline team can then receive now active help from the previously formed platform team and the previously formed streamline team during their cloud journey. So the platform team, for example, can suggest possible cloud options applicable for their bounded context, or also can coach them how to use a CI/CD pipeline in a serverless ecosystem, or they can also point to the platform as a service that they have established before, and can also incorporate the feedback from using that platform as a service that they have provided. And the first formed streamline team can also coach the new streamline teams and, for example, sharing knowledge, for example, coach them about best practices, how to implement serverless function, for example, in a hexagonal architecture. And the next streamline teams can go on their journey, and they also receive then active help from the other teams during their refactoring cloud journey. So that at the end, we were able to refactor our monolithic big ball of mud into the modular bounded context with high functional cohesion, and we formed the streamline and platform teams and aligned their interactions to support the cloud migration journey. And we also established well-defined ownership boundaries and eliminated the delivery bottlenecks and have optimized our system for flow. And we do not need to stop here, so then we can also continue creating additional Wardley maps or value chains for the internal users as well. So, for example, if we switch to the X as a service value chain, now the streamline teams become now the internal users of our value chain at the top. And the streamline teams, they have the user needs of building and testing, releasing and deploying, operating and monitoring the bounded context of service, and provision also infrastructure for the bounded context or service. And to fulfill these user needs, now the streamline teams, to fulfill the user needs of the streamline teams, one scenario could be that the platform team or multiple platform team can provide a variety of X as a services. A pipeline as a service supports the streamline teams to build, test, release, and deploy the bounded context or service. And a pipeline as a service is built on top of other components, such as version control system, CI/CD pipeline, build server test automation, and so on. And to operate and monitor a service, the streamline teams require dashboards, alert mechanisms, observability capabilities like log management, metrics handling, distributed tracing, and these capabilities can then be provided by the platform team as a monitoring as a service. And also, platform as a service then enables the streamlined team to provide the runtime environments that the services need, including those components that are needed for the runtime, such as database, search engine, message broker, and so on. And we might identify some capabilities along that, and that's where the enabling teams now blend in. And from the facilitation value chain perspective, the streamline teams and the platform teams are now the internal users of our value chain. So the cross-functional autonomous streamline teams, they need to cover a wide range of capabilities such as software design and architecture, application security, user experience, accessibility, software design, testing and QA, product management. So that is a lot to cover. And that's where the specialists of enabling teams can come in and identify and bridge the capabilities of the streamlined teams. And they also can support the platform teams as well, from an enabling team perspective. For example, by coaching them what is important to achieve good developer experience, or how to design a good API, or how to write good documentation. Plus, the enabling teams can also support the platform teams on skills related to effective communication, improvement of practices such as team coaching, mentoring, process improvement, and product management. But you might object, no. We are so successful, we don't have to change. I mean, that is fine as long as you have no competitor, or your competitor are less efficient or less evolved than you are. So, but maybe if you say this, then you are suffering from inertia to change. And inertia to change created by past success, that's blocking the evolution of components. The inertia to change increases the more successful your past model is, as one of the climatic patterns. And it's not the lack of innovation that can kill an organization, but their inertia to change. For example, Nokia was in fact very innovative. They invented their first smartphone in 2005. That was 2 years before Apple came out with their first iPhone. But Nokia was still so successful with their old cell phone model that they were very reluctant to fully transition to the smartphone era. So being successful, and they also, within 6 years, their market share declined by over 90%. So being successful today doesn't mean that you stay successful tomorrow when the world around you changes. When the market changes, you have to change too. So in investing in building adaptive socio-technical systems that are optimized for a fast flow of change equips you to thrive in the face of constant changes. You are now in a position where you are not only able to respond to changes and changing circumstances, but you are now in a position also to leading the change. For example, you can now create additional differentiating value, increasing your competitive advantage in the market. You can now be the first mover to commoditize components that others can innovate on, and that enables you to identify usage patterns where you can derive new components that you can commoditize. And you can also build cooperations and alliances with others to accelerate the evolution of your components, also increasing your ecosystem. Now you are in the driving seat of change. The good thing is that you can start small. You don't have to know everything in detail before starting it. So you can start with parts that are mostly useful for your current context. For example, you can start with creating a Wardley map that represents the competitive landscape you're operating in. And you can use this as a foundation as a structured method to share it with others and challenge your assumptions and gaining a common understanding of your landscape. Or you can start with your current team, analyzing your current team constellations and assess their current cognitive load and blocking dependencies and bottlenecks. Or you can also start with your current software architecture. All your components are tightly coupled, and it can help you to also to start with identifying suitable themes to leverage modularity with high cohesion and loose coupling. And this with the aid of subdomains and bounded context is one approach. And at some point, their paths eventually cross, so that enables you to follow the architecture for flow. So the combination of Wardley Mapping, domain-driven design, and Team Topologies helps you to understand the competitive landscape you as an organization is operating in, including what external forces are impacting your landscape, to anticipate some changes, to anticipate some opportunities, and identify potential points to invest. It helps you to gain domain knowledge and discovering the core domain that provides competitive advantage. It helps you to know what components to build in-house, where to buy or use off-the-shelf products or open source software solution, or outsource to utility suppliers. It helps you to leverage modularity with bounded context as well-defined ownership boundaries, and also good modular components with high cohesion and loose coupling. It helps you to align your teams and evolving their interaction to the system you build and the strategy you plan, and also identify potential efficiency gaps and eliminate the delivery bottlenecks, and increasing your software delivery performance and increase your responsiveness to change. So the combination of Wardley Mapping, domain-driven design, and Team Topology provides a powerful, holistic toolset to design, build, and evolve adaptive socio-technical systems that are optimized for fast flow of change in order to be able to adapt quickly and evolve and thrive in the face of constant change. And with that, I share some resources that you can also dive deeper into. And yes, there is also a book still in the progress. And thank you so much for attending my talk.
Thank you very much, Susanne. Now we have a little time for a few questions because we are 1 minute behind schedule. So let's see the Slido link, and now we have a few questions. Let's start with the most liked one. How can we best design our org for work that cuts across multiple bounded contexts? We still face dependency and scheduling challenges.
So if you have work that cuts across multiple bounded contexts, means either like to identify whether the themes are correctly placed, for example. If this is like, for example, if you're following, so a bounded context can follow different areas, like they can group related business behavior together or following a user flow. But usually is when you work across multiple bounded contexts, you can also design well-defined APIs, how to use your the bounded context that you're working across, so that you then makes the other self-sufficient, so that you don't have to communicate and coordinate a lot.
Okay, let's see a second one. Are companies doomed to go bankrupt if they don't divide their core boom into separate bounded contexts, each in a stream-aligned team? Should I jump ship?
No. So legacy systems are usually so legacy systems are usually growing organically, and they become over the time a big ball of mud, the B-bomb. But they made you successful from the past, and that's what they brought you to the situation that you're right now. So you don't have to decompose your big ball of mud completely in separate bounded contexts, but you can start to identify areas where, for example, specific parts of your system require different architecture characteristics. For example, where you have to scale, or where with areas that are changing very frequently, and you can start with identifying themes for bounded contexts that are fulfilling these requirements, and start there. And then you can also use your current legacy system, could still be active, and could be, for example, you can integrate with that one, for example, with anti-corruption layers, and still remain active, but maybe consider more, could be more the parts that are changing less frequently than the others that you have decomposed. So still, it doesn't mean that you have to 100% completely decompose your big ball of mud into bounded context.
Thank you very much for your answers.